Alright guys, welcome to chapter 7.2 inverse trig functions. We're just going to continue on from last time. Doing a little bit different than what we did last time, but not too much. So we have a few objectives to get to today. I'm not sure how far I'll get in this video, but let's start off with objective 1, finding the exact value of an expression involving the inverse sine, cosine, and tangent. Okay, so this is kind of a continuation from last time. So here, notice though, that we are trying to find the sine of a tangent function, the inverse tangent function. Notice if there's an inverse inserted into a regular function, this whole thing can be replaced with a theta, because we know that an inverse finds us an angle, okay? So what we got to do is we got to figure out what that theta is. Okay, so for tangent, we want to first evaluate the tangent of 4/3. So what is tangent? Again, tangent is y over x, right? We know that the tangent function that we care about happens between negative pi over 2 and pi over 2. Okay, but we're looking for the sine. Okay, so we're going to use this idea to figure out what quadrant we're in. So if we have 4, 3 for our tangent, we know that the y value is positive, the x value is positive, or they're both negative. But in this particular, because of how we define tangent and where its domain is, we know that it has to be in quadrant 1. Okay, so now that we know that, we can actually draw a triangle. And I encourage you to draw triangles today. We know that the y value in this triangle is 4. The x value is 3. And we can find the hypotenuse using the Pythagorean theorem. Okay, so we can say, all right, well, 3 squared plus 4 squared has to equal r squared. That comes out to 25, I believe, equals r squared. So r is equal to 5. Once we know that, we can use that to help us define sine, because sine is simply y over r. Okay, so that's what they're doing, showing you guys on this next slide here, where they solved and got 5. So we will replace this tangent of 4/3 with now the theta. The theta happens at 4 over 5, because that is the y value here over the r value, 4 over 5. So sine of theta is equal to 4/5. Okay, so that's all they want for this one. They're not looking for, you notice you're finding the exact value of the expression, right? So they're not looking for the actual theta. We use the theta of the first function and insert it into the second. All right, so for example 2, same deal. Here we're looking at sine, inverse sine of negative 4/5. Remember, sine is y over r, and sine function happens here between negative pi over 2 and pi over 2. That means that, and I know that my radius is positive, right? My radius is always going to be positive. It's a distance. Therefore, my y value is negative. So if my y value is a negative, I'm going to be somewhere down here, so I'm in quadrant 4. All right, so now I can use the exact same method I did last time. So since sine is y over r, I happen to know, so I'll just make another triangle here. I know that my hypotenuse is 5, and I know that this value is negative 4. So I can use the Pythagorean identity to figure out this guy. It's a 3, 4, 5 triangle. Okay, I know that from last time, and it's just a common right triangle. So I know that my x value is going to be 3. All right, well, that's what I'm looking for, because the cosine is equal to the x value over the r value. Okay, so I know here that I'll be at 3/5. Okay, so the cosine of the sine inverse of negative 4/5 is 3/5. All right, so that's what all this was telling us. Let's keep cruising. I think I want to get into at least one more example with you guys. Find the exact value of the tangent of the cosine of negative 1/3. Okay, so for this one, remember that your domain for cosine is up here, right? It's between 0 and pi. If we have a negative 1/3 here, we always know that the r value is positive, therefore we're at negative 1 on the x. Okay, so we're at -1 on the x. We have an r value of 3. Okay, so this is 3. This value here is 1. So we can draw the triangle, right? So we have 1 squared plus y squared is equal to 3 squared. So y squared is equal to 8. Therefore, y is equal to the square root of 8, which is equal to 2 root 2. Okay, when you simplify that down. All right, so the y value is equal to 2 root 2. I know my x value is equal to -1. So tangent is equal to y over x. Okay, so the y value here, again, is 2 root 2. The x value is -1. So this just becomes -2 root 2. Okay. Which is what they get right there for example 3. I think that might be all that I do for you guys today. That should be enough to get you started on the lesson. And just remember, going into objective 2 here, what these things mean: secant, cosecant, cotangent. That's just a 1 over. Okay, so for secant, it's going to be a 1 over the cosine, right? So this would be 1 over x. This one would be 1 over y. This one would be x over y, right? Eventually, like when you simplify it down, that's what it comes out to. All right, so then by definition here, you might want to get this into your notes. It gives you the domain that we have to be concerned with. Remember that with some of these, there's going to be restrictions because they're undefined in certain areas. Okay, so this maybe take a minute to jot down this slide here. But then once you know that, you can use that in your Pythagorean identities to solve these guys. And we'll do some of those together in class. Catch you guys next time.